fractions. Let's just look at a few definitions of fractions, and then also how to add, subtract, multiply and divide by fractions. These are very basic stuff that you feel like this is primary school work, but there's a lot of cases in high school where you get to difficult problems and algebraic expressions and algebraic fractions that you have to simplify, where the basic rules apply, and if you don't know the basic rules then you struggle. So let's just look at the definitions first. You get proper fractions, and know the difference between these when I refer to them. Then you get improper fractions, you get decimal fractions, and you also get mixed fractions. These are just words, and when I say leave as a decimal fraction or leave the answer as a proper fraction or simplify to an improper fraction, it's just good if you know what I'm talking about. Now, proper fractions is fractions where the numerator is smaller than the denominator. This is usual fractions like you know them, like a half, 2/5, 6/7, etc., where the numerator, the top number, is smaller than the denominator, the bottom number. Improper fractions are things where the numerator is bigger than the denominator. So for instance, 2/1, 5/2, 7/6, like that. 7/6, and that will be called an improper fraction, where you can see the top number is bigger than the bottom number in these fractions. Then decimal fractions are things like 0.6, 1.2, 0.159, 99999. Basically the rational numbers written in decimal form, or numbers with a comma in them or a decimal point in them, are called decimal fractions. And then mixed fractions are if I simplify the improper fraction to just one fraction with a number and a proper fraction again. For instance, 3 1/3, 1 1/4, 2 2/5, like that. Then I have a mixed fraction. Right. It might be worth also just remembering before we continue the plus minus rules for multiplication and division. Now this is let me just make some more space. This is something you're supposed to know, or you probably have heard this before and you know it without me even saying this, but a positive times a positive always gives me a positive. A negative times a negative also gives me always a positive, and then a positive times a negative gives me a negative always, and a negative times a positive gives me also a negative always. Right, now most of you know that this works for multiplication. I don't know if you know that this also works exactly like this for division, which most of the time when teachers tell you that a plus times a plus is a plus, they don't tell you a plus divided by a plus is also a plus, and a negative divided by a negative is also a plus, which means if I have a fraction -1 over -2, this is a negative divided by a negative, and it works exactly like that, and that means I have a positive fraction. And something else that this also means is that I can write a fraction with a negative in it. So for instance, -1 over 2 is a negative divided by a positive. Can you see that will give me a negative number? and also a positive divided by a negative will also give me a negative number with that fraction. And this rules now gives me the ability to just know that whether I write in a fraction the minus there, or the minus there, same thing. But it is better for most of the time. I prefer using this form. So if there's a negative in the numerator or the denominator, I just write it in front of the fraction. Because when I work with a lot of fractions, say for instance I want to add 3 over 4 plus minus 1 over 2 minus 2 over negative 3, and I have a lot of minuses and pluses, then it's just easier to write it like this, and I can work with it a little bit easier, right? So let's quickly look at adding and subtraction of fractions. Now when you add and subtract with a fraction, what you want to ultimately do is you want to get the denominator the same. So if I have, for instance, a half plus 3 over 4, I want to get the denominator the same. I do that by getting equivalent fractions, which means I multiply top and bottom with the same number. Here it will be 2. So I multiply top and bottom of the first fraction with 2, and I add that 3 over 4, and then I have 5 over 4, which is an improper fraction, and I rather want to leave it as a proper fraction. Right. To make a little bit of sense what is happening here and why you keep the denominator the same, why you want the denominator the same, and then you just add the numerators. We want to also add the denominators, but just to show you why it works like that. Say for instance I have here a block that I divided. I know I'm going to use 2 blocks because I have a little bit more than one here in the answer. Say for instance I have 2 blocks that are divided into quarters. If I have 2 quarters, which is a half, 2 quarters, and you can see that this is half of the block, and I have another 3 quarters, 1, 2, 3. Just make sure, can you see, understand the concept that I now have 5 quarters that I'm working with and not 5/8. The quarters, the size of the fraction that I worked with stayed the same. I just added the amount of that, and that is when I add and subtract what I'm going to do always. I'm going to keep my denominator the same even after I add it. I make the denominator the same, and then I just add the top ones. It works differently for multiplication and division. Also make a mental note of that. So when I add, I'm going to get the denominators the same and add the numerators. Let's quickly look subtraction. If I just work this question back, if I subtract 1 1/4, if I subtract 3 quarters from that, I should get a half. Let's see if that happens. With subtraction, it's going to work exactly the same. I first just want to write this as an improper fraction because it's difficult to add and subtract if I now have numbers and fractions. I write this as an improper fraction. Hopefully you know how to do this. I multiply with the bottom number and add the top number, this number here. I multiply by 4 and add 1, which gives me 5, and that's my new numerator, and my denominator stays 4, and then I subtract 3 over 4. And now same thing than happened with the plus. I keep my denominators the same, and I just subtract because there's a subtraction sign or a minus now, and I just subtract the numerators. 5 minus 3 is 2, but I keep the denominator the same. And 2 over 4 can simplify then to a half. Right, and this method follows through to algebraic equations, and when I work with variables and x's and y's. I just want to show you quickly an example that looks like that. Say for instance I have x over 2 plus 4x over 3. This is now simple examples. I just want you to get the concept. I first want to make the denominator the same. So I think I'm going to multiply this by 3 and multiply this by 2, and then whatever I do at the bottom I must also just do at the top. So if I multiply by 3 at the bottom, I'm multiplying by 3 at the top. And for this one, if I multiply by 2 at the bottom, I multiply by 2 at the top also. And then I have 3x plus 8x over 6, 3x over 6 plus 8x over 6. And I'm going to do exactly the same as what I did in the previous example. Now I just add the numerators, which is 3x plus 8x is 11x, and I keep my denominator the same. Right, and you can write this as 11 over 6x or 11x over 6, same thing. I prefer again using this format. The reason for that is when I work in an equation, if I have for instance 2x squared plus 11x over 6 minus 2 versus if I have 2x squared plus 11 over 6x minus 2, can you see that this is closer to standard form, and this is the same thing, but this just makes a little bit more sense in an equation. Alright, and then the same for minus. If I have x's and y's, I can also subtract fractions by just getting the denominator the same and then subtracting the numerators and keeping the denominator the same. Right, so let's quickly look at multiplication and division when I work with fractions. Multiplication and division works as follows. The first thing about multiplication and division is when I multiply to, I'm first just going to talk about multiplying, and then I'm going to go to division. When I multiply with fractions, you remember now with adding and subtracting, I add the tops and keep the bottom the same. It doesn't work like that with multiplication. With multiplication, I multiply the tops with the tops or the denominators, and I multiply the numerators with one another. So I'm going to say 1 times 2 is 2 and 2 times 5 is 10, and I'm just going to simplify this fraction by dividing by 2 both top and bottom, or in the numerator and the denominator, giving me 1 over 5. Alright, something else you can do before you start multiplying the numerators and the denominators is you can see if there's anything, one thing at the top and one thing at the bottom which has the same factors, things that can divide in both numbers, a number on the top and a number on the bottom. It doesn't matter, it doesn't have to be in the same fraction. For instance, here I have a 2 and there I have a 2, and both these numbers can be divided by 2, giving me 1, and then I can go and take the numerator times the numerator gives me 1, and the denominator times the denominator gives me 5. When I work with larger fractions, it might be easier to first just go and simplify the fractions and make them smaller before you start multiplying. So this is the procedure you follow for multiplication. Is you can see if you first can simplify a little bit, but main thing you have to remember is you multiply the numerators with the numerators and you multiply the denominators with the denominators. What happens with division is actually pretty simple. Say for instance I have a half divided by 2 over 5. So I have a half divided by 2 over 5. I just put in one extra step before I start doing this problem. I take a half and I multiply it by 5/2. So I've changed the division into multiplication, and then I just use the reciprocal of the second fraction. Reciprocal means I swap the denominator and the numerators with one another. Right, and then I can multiply. So I multiply the numerator with the numerator and the denominator with the denominator, giving me 5/4. And I'd rather write it as a mixed fraction, 1¼ 4 goes into 5 one time. That's where this one comes from, and then there's 1 left, and that's where that one comes from. There's 1 what left, 1/4 left after that. Alright, and same thing, you can use these procedures. If you know how to multiply and divide with fractions, you can pull the concept through to working with variables. Say for instance I have 2x/3 multiplied by 4/6x. I can either do this by just taking the numerators and the denominators and multiply them. 2x times 4 gives me 8x, and 3 times 6x gives me 18x. And then this can simplify. I can divide 8 and 18 both by 2, giving me 4/9, and the x's cancel out, so I have 4/9 as a fraction. But you can also first simplify this here by seeing that there's an x that can cancel out. I can divide the 4 and the 6 by 2. So I divide 4 by 2, giving me 2. I divide 6 by 2, giving me 3. And then there's nothing I can cancel out anymore. And now I have 2 times 2, which is 4/3 times 3, which is 9. Alright. And that's the basics of it. Let's just quickly go and see if I have a division problem with x's or y's in them. Say for instance I have 2x/3 divided by 4/6x. What I'm going to do, the first step is I'm going to just change this division to a multiplication and use the reciprocal of that fraction. So the 6x goes on top and the 4 goes on at the bottom. And now I can first simplify a little bit. I can see I can divide 3 into 6 and 3. So 6 divided by 3 is 2, and 3 divided by 3 is 1. And I can also divide 2 here and here, or there and there, it doesn't really matter. So I divide 2, leaving me 1, and I divide 2, giving me 2. And now I multiply the 2x with the x, giving me 2x squared. Oh, there was another 2 I could have cancelled out. And the 1 times the 2 gives me 2, and that can also cancel out, sorry, leaving me with x squared. Alright. Okay, so that's the basic procedure of multiplication and division, and addition and subtraction. It is worth just taking note that this thing that I did here now with the division, I can also do if I have more than one fraction that I'm dividing. So for instance, I have a half divided by 2/3 divided by 3/4. This is a very easy question. Divided by 4/5. So for instance like that, I can use the same rule by making the division and multiplication and changing the fraction just after that. Just take note, this first fraction stays the same. If I change the division to multiplication, instead of dividing by a fraction, I can multiply with its reciprocal. So there I change this one into a reciprocal, but can you see the half stays? And then if I have more, I'm just going to repeat that to change this to a multiply, and then I make this the reciprocal. And there's a division, I change that to a multiplication and I use the reciprocal. Oops, that's not the reciprocal. I was wondering why there's now two 4's next to one another there. Okay, and then as you can see, the 3 and the 3 can cancel out, the 4 and the 4 can cancel out, leaving me at the top with 1 times 5, and in the denominators with 2 times 2, and I'm ending up a lot at 5/4 today, but this is still 1 1/4. Alright, so it is worth it to approach more difficult problems as you go along in algebra, to just be familiar with the basic procedures of fractions and be familiar of the words of fractions. And it's a good idea to know these plus minus rules off by heart also, and know that they not only apply for multiplication, they also apply for division.